So my project is called SoundSphere, and what I try to do is to realize a synthesizer or control surface of synthesizer in a VR space. These horizontal lines represent a pitch. For example, if I want to play A4, then I point A4 and press trigger. Then I can play A4 sound. B4, C#5, like this. Then if I want to play C major scale, so it's somehow possible to play a melody using these horizontal lines. As you see, there are black lines and white lines, so these are kind of borrowed from piano key color. If we want to disable this horizontal line, just touch this 3D icon or button, then you can disable. And if you touch again, then you can enable. There are also vertical lines. This line has a level like 100 Hz, 850 Hz, and these are resonant frequency of filter. So if I play A4 sound like this and rotate left and right, then you can hear the change of timbre. And for example, if I want to emphasize lower frequency component of sound, then I can just rotate towards left, then I can emphasize lower frequency. Or if I want to emphasize higher frequency component, or in other words, I need a brighter sound, then I just rotate towards right, then it sounds brighter. Also, in order to change the timbre, you can roll your hand. So this is a standard sound. This is called sine wave. So you can generate sine wave. But if you rotate your hand towards left, then you can generate sawtooth wave-like sound, very bright and harsh sound. And if you wanna generate another sound called square wave, then you rotate your hand towards right, then you can generate like Game Boy-like sound. And these are also influenced by the angle. So this is square wave with the emphasis on the higher frequency component. And if I rotate, I can also change the timbre. And this is sawtooth. With resonant frequency change. So you can control the timbre by rotating your hand and rotating yourself. Like this. Probably the most unique aspect or feature of this project is this visualizer. Obviously, this is FFT spectrum visualizer, but this has two unique features. For first feature is you see the many layers behind one FFT representation. Actually, this visualizes chronological FFT change or spectral change. And the second feature is, as you see, there is a yellow bars. This represents spectral centroid. This represents how bright the sound is. And if I play pointing the middle line here, I just play sawtooth wave. The yellow bars around here, but if I move towards left, then I can emphasize low frequency component using resonant filter. Then yellow bars are around here, so it represents how bright the sound is. It follows actually my hand when I move left to right. I'd like to introduce the most interesting feature as a synthesizer. We have actually two controllers. We can generate sound with right hand and sound with left hand, but we can combine two hands. So if I press left hand first, then right hand, so we don't hear two sounds, but kind of metallic sound. So this is called FM synthesis. And I'd like to briefly introduce how it works. Actually, FM synthesis is vibrato. Vibrato means you fluctuate the pitch, like this is A4, and you just fluctuate this pitch. So if you do that with your hand, this is vibrato, but you can automate that using second hand. If I press A4 and you point with right hand your floor and press. So you actually vibrate or fluctuate the pitch automatically using your right hand. Like this. But you can control the speed of this fluctuation. The speed is really fast, then you can't recognize this as a vibrato. And you can recognize it as a different sound. So this is called FM synthesis. And if I press the trigger of my left hand first, this functions as a carrier, which generates just sound. And then if I press the trigger button of my second controller, then this functions as modulator, which fluctuates the frequency of first carrier oscillator. The modulator waveform you can control also with this roll. Modulator amplitude you can control with some stick. And the modulator is also influenced by resonance filter.